Welcome to lesson 1-6, solving absolute value inequalities. So what we're going to do is we're going to solve the absolute value inequality. Absolute value of A is less than B. So let's discuss a more concrete one. The solutions to the absolute value inequality, absolute value of x is less than 5, include values greater than -5 and less than 5. This is a compound inequality where x is greater than -5 and less than 5. That's because we're going to take any value in here that we can absolute value and have the ultimate value less than 5. So that could be 4. Absolute value of 4 is less than 5 because absolute value of 4 is 4, which is less than 5. So 4 works, 3, 2, 1, and 0 work, where all these values can be absolute valued and be less than 5. So does -1, -2, -3, -4. Because all those values, -1, absolute values to 1 is less than 5, and all the way down to -4. But I can't go any further down the number line because what if I got to -5? -5 absolute values to 5 is not less than 5, it's equal to 5. What if I went further to -6? -6 absolute values to 6 is not less than 5, 6 is bigger than 5. So I can't go any further than this down in the number line or up the number line. Okay, so then we have that x has to be greater than -5, so -4, -3, -2, -1, and less than 5, like 4, 3, 2, 1, 0. Okay, and at the same time. So it has to be bound in that list of numbers or anything in between them. Okay, to solve an absolute value inequality, you will still have two cases. Case 1, the absolute value inequality with the positive value, and case 2, the absolute value inequality with the negative value with the reversed inequality sign. To find the solution to the absolute value inequality, or find the solution, and graph the solution on a number line. So what I'm going to do is these two cases, the positive case and the negative case. In the positive case, I'm going to take out 2x minus 1 is less than 5. In the negative case, though, I'm going to take out 2x minus 1 and say it's greater than -5. So there's two changes in the negative case. All right, so then I'm going to draw a line and solve. Add 1 to the other side. 2x is less than, 6. Divide by 2. X is less than 3. Okay, add 1 to the other side. 2x is greater than -4. Divide by 2. X is greater than -2. All right, so x is less than 3, but greater than -2, and less than rhymes with and this is an and type of thing, so we're looking for the overlap. Okay, and right here's the overlap from -2 to 3, so we say from -2 to 3 is our final solution set. Okay, all right. Number 2, we have an absolute value inequality. Let's first get the absolute value signs alone. So subtract 5 from both sides. 2, absolute value of 3x minus 4, close it up, is less than or equal to 16. Divide by 2 on both sides. Absolute value of 3x minus 4, close it up, is less than or equal to 8. Now take two cases. Take out the 3x minus 4 is less than or equal to 8. Take out the 3x minus 4. This time is greater than or equal to -8. Two changes in the second case. Okay, go ahead and solve. Add 4. 3x is less than or equal to 12. Divide by 3. X is less than or equal to 4. Over here, add 4. 3x is greater than or equal to -4. Divide by 3. X is greater than or equal to -4/3. All right, plot them. X is less than or equal to 4 and greater than or equal to -4/3. here's your overlap. We have -4/3, comma, 4, with brackets on either side because of the closed circles, because of the underlines, because of that underline up there. All right, solving the absolute value inequality with greater. So if less than gives you an and, greater is going to give you an or. Okay, so absolute value of x is less than 5 means x is between -5 and 5. So the absolute value of x is greater than 5 means x is outside the interval from -5 to 5. Therefore, we can say x is less than -5 or x is greater than 5. That's because anything that's bigger than 5 could be 6, 7, 8, 9, 10, and on up the number line, or -6, -7, -8, -9, -10, and down the number line, but not in between. Okay, so it will look like an or. Okay, find the solution to the absolute value inequality, graph the solution on the number line. So here I have absolute values greater than or equal to 6. I'm going to go right into 2 cases because I don't need to isolate the absolute value because it's already isolated. Okay, so it's already isolated, so I don't have any of that work, so I'm going to go right into my 2 cases. 2x plus 4 is greater than or equal to 6, or 2x plus 4 is less than or equal to -6. All right, subtract 4 from both sides. 2x is greater than or equal to 2. Divide by 2, x is greater than or equal to 1. Over here, subtract 4 from both sides. 2x is less than or equal to -10. Divide by 2, x is less than or equal to -5. Notice that we so far have not divided or multiplied by a negative number, so I'm very careful that I'm looking for that at all times. This time we divided by a +2, so we didn't divide or multiply by a negative. That would be when I need to reverse my inequality symbol, if you remember that factoid. Okay, x is greater than or equal to 1, so close it up, head to the right. X is less than or equal to -5. Close it up, head to the left. All right, so our interval notation will look like this: -∞ to -5, bracket, or bracket 1 to infinity. Okay, number 4. Oh look, that absolute value has neighbors. Let's isolate the absolute value. Subtract 1. Divide by 3. Then 2 cases. I'll do them over here. 5x plus 10 is greater than 15. 5x plus 10 is less than -15. Okay, subtract 10. 5x is greater than 5. X is greater than 1. Subtract 10. 5x is less than -25. X is less than -5. Plot them. X is greater than 1, less than -5, and we go from -∞ to -5, or 1 to infinity. Okay, that's all for today, folks. Good luck. Remember, when you divide or multiply by a negative, you need to switch the inequality symbol in the solving steps. Also, remember that you need to try to remember the first 2 syllables, less than, rhymes with and the first 2 syllables, greater, rhymes with or, that you're going to get those stereotypical ands or ors, okay, on the graphs. All right, guys, good luck with your homework.